Welcome to this course about Linux commands and shell scripts. In this course, you will explore how to get started with using Linux and the most commonly used shell commands. You will recognize that a shell is a powerful user interface for Linux and Unix-like operating systems. It can interpret commands and run other programs. It also enables access and interactivity with files, utilities, and applications. Additionally, you will discover how to create shell scripts to automate tasks, run batch jobs, and quickly create useful programs. This course has 3 instructors: Ramesh Sonareddy, Rav Ahuja, and Sam Prokopchuk. Ramesh Sonareddy is a seasoned subject matter expert with SkillUp Technologies. Rav Ahuja is a global program director at IBM and the architect for several IBM professional certificates. And Sam Prokopchuk is a data scientist and software developer at IBM. Now, learning Linux commands and shell scripting, Bash in particular, also makes you more flexible whether you are a software developer, data scientist, data engineer, systems administrator, DevOps professional, system architect, or software engineer. Once you have a good understanding of Bash commands, it's relatively easy to write scripts that simplify the building process of all sorts of data pipelines and application workflows. In this course, you will learn all about the basics of Linux, the use of common Linux commands, and the basics of shell scripting with Bash. We will start off with an introduction to Linux. You will learn about the origins of Unix and Linux, the architecture of a Linux distro, and how to accomplish simple tasks in a Linux terminal. You'll then explore commands for collecting user information, accessing variable values, and printing useful output to the terminal window. You will learn how to navigate your file system by listing your directories and their contents, determining where you are within your directory tree at any time, moving to other directories with ease, and quickly finding the files you need. You will also learn how to manage your files and directories by creating new directories, removing unwanted directories, creating new files, and copying and moving files and directories. You will learn how to view the contents of your files in various ways, for example, using the cat command and the more command. You will also discover how to get useful summary information about the contents of your files. You will also gain experience with creating customized views of your file contents, for example, by sorting the contents line by line, excluding repeated lines from the view, and extracting particular sections from each line. You will get hands-on experience with archiving the files and directories in a directory tree, extracting files and folders from your archives, and extracting and decompressing files from zipped archives. And you will also gain skills by applying networking commands, for example, determining your host name, getting detailed information about your network configuration, and conveniently downloading files from the web. We'll continue with an introduction to shell scripting. You will explore all aspects of scripts and Bash shell scripting, what shell scripting is used for, and how to create and run your own shell scripts. You will also gain valuable knowledge about filter commands and chaining your filters together using the pipe command. In addition, you will learn about defining shell variables and environment variables. You will discover useful features of the Bash shell along the way, including the use of meta characters, input and output redirection, and passing arguments specified on the command line to your shell scripts. You will also discover how to put your shell scripts into production by learning all about the cron service for running jobs, scheduling your jobs with cron tab, and viewing and editing the cron jobs currently running on your system. Finally, you will put your newly acquired skills to the test by completing a hands-on project that involves various Linux commands and building a shell script. To get the most from this course, watch every video and check your learning by taking the quizzes. Use the discussion forums to connect with your peers and the teaching assistants. And most importantly, make sure you complete the hands-on labs to practice your new skills and demonstrate your abilities. Congratulations on beginning the next step of this exciting journey, and good luck! Welcome to Introduction to Linux and Unix. After watching this video, you will be able to explain what an operating system or OS is, describe the origins of Linux and Unix, and list some of the features of Linux and Unix. What is an operating system? Well, it's software that manages computer hardware and resources and allows interaction with hardware to perform useful tasks. So, what is Unix? It's actually a family of operating systems. Some popular Unix-based operating systems include Oracle Solaris and Open Solaris, FreeBSD, HP UX, IBM AIX, and Apple macOS, which is one of the most popular desktop operating systems today. In the 1960s, the original Unix OS was created at AT&T Bell Labs. However, like many operating systems at the time, it was made for a specific hardware system, in this case, the PDP-7 computer. In the 1970s, the Unix OS was rewritten in C, distinguishing itself from other systems and making it portable to many hardware architectures. And then, in the late 1970s, UC Berkeley developed Berkeley Software Distribution, or BSD, an add-on to Unix providing additional software and capabilities. The famous Mac OS was later derived from BSD. So, what is Linux? Linux is a family of Unix-like operating systems. However, when referring to Linux, people are usually talking about a specific distribution or flavor. Linux was developed as an effort to create a free open-source version of the Unix OS. Key Linux features include the following. Linux is free and open source, which means anyone can view the source code. And with so many eyes on the source code, Linux has become the most secure OS over the years. It's multi-user. Linux is designed to support multiple users accessing the system simultaneously. It also supports multitasking, running multiple jobs and applications at the same time. And it's portable. Linux has been ported to run on many different types of devices and hardware platforms, from desktops to servers to appliances. How did Linux start? In the 1980s, GNU was developed at MIT. GNU stands for GNU's Not Unix and was made as a free open source set of the existing Unix system tools. And in 1991, Linus Torvalds developed a free open source version of the Unix kernel called Linux. The kernel is the core component of an OS that enables components to communicate with the machine's hardware. Here is Linus Torvalds' famous post, where he shared his progress making his own open-source Unix-like kernel. He references Minix, which was another Unix-like kernel at the time. Soon after, in 1992, the potential of unifying GNU and the Linux kernel was realized as popular Linux operating systems began to appear. And in 1996, a computer scientist named Larry Ewing created Tux the Penguin, which was later adopted by Linus Torvalds as the official Linux mascot. Today, the BSD-based Mac OS runs on millions of devices across the world. Billions of Linux instances run on servers, serving us the modern web. And especially among developers, modern Linux operating systems, such as Ubuntu, are beginning to gain popularity in the PC space. Okay, well, what are the most common use cases for Linux today? First, it's used in billions of smartphones around the world via the Android operating system, which uses a Linux-based kernel. Linux is also widely used in supercomputers where many Linux-powered servers are clustered together for high-performance computing applications. Enterprise and cloud data centers also use Linux over millions of servers running all kinds of applications, web servers, databases, and so on. And finally, versions of Linux can easily be used as your PC's operating system. Many people install Linux today as a learning experience or as their daily driver. In this video, you learned that Unix is a family of operating systems dating from the 1960s. Linux was originally developed in the 1980s as a free open-source alternative to Unix. Linux is multi-user, portable, and supports multitasking. And Linux is widely used today in mobile devices, supercomputers, data centers, and cloud servers. Welcome to Overview of Linux Architecture. After watching this video, you will be able to list the layers in a Linux system, describe the role of each layer in a Linux system, and describe the Linux file system. The Linux system comprises 5 distinct layers. The user is the person using the Linux system. Users interact with the system via the application layer that includes system daemons, shells, user apps, and tools. The applications communicate with the operating system to perform tasks. The OS is responsible for jobs that are vital for system stability, such as job scheduling and keeping track of time. All Linux operating systems are built on top of the Linux kernel, which performs the most vital lower-level jobs. The kernel is the core component of the operating system and is responsible for managing memory, processing, security, and so on. The kernel interacts with the hardware layer, which includes all the physical electronic devices in the computer, such as processors, memory modules, input devices, and storage. The first component in a Linux system is the user, or the individual using the Linux machine to perform tasks. You might use a Linux machine to use a web browser to send your friend an email, or use a music player to listen to your favorite song. Applications are the software that enables a user to perform a task in a Linux system. Applications can include the following: system tools such as compilers, programming languages, shells, which are special applications that are often part of the operating system itself, and user apps, which can be anything from browsers to text editors to games. The operating system controls the jobs and programs that are vital to system health and stability. It also provides these functions: assigns software to users, helps detect errors and implements measures to prevent complete system failures, and performs file management tasks. In a Linux system, the operating system is built on top of the Linux kernel, which performs the most vital operations. It is the lowest level software in a Linux system and has complete control of the system. The kernel starts as soon as your computer boots and remains in your computer's memory while it's running. It acts as a bridge between your apps and your machine hardware, enabling the two to communicate effectively. The kernel has 4 key jobs: memory management, process management, managing device drivers for proper hardware support, and system calls and security assurance. The final layer in the Linux system is the hardware, consisting of the physical electronic devices that make up your computer. This layer can include the following: the Central Processing Unit, or CPU, which is responsible for executing most calculations; the Random Access Memory, or RAM, which is a fast storage unit used to hold the temporary information your applications need to run; storage for data that needs to persist when your computer is powered off; your computer's screen; and any USB devices, such as a keyboard, mouse, or USB drive. The Linux file system is the collection of files on your machine. It includes the files needed to run the machine and applications, as well as your own files containing your work. The top level of the file system is the root directory, symbolized by a /. Below this is a tree-like structure of the directories and files in the system, and the file system assigns appropriate access rights to the directories and files. The very top of the Linux file system is the root directory, which contains many other directories and files. One of the key directories is /bin, which contains user binary files. Binary files contain the code your machine reads to run programs and execute commands. It's called /bin to signify that it exists directly below the root directory. Other key directories include /user, which contains user programs, /home, which is your personal working directory where you should store all your personal files, /boot, which contains your system boot files, the instructions vital for system startup, and /media, which contains files related to temporary media, such as CD or USB drives that are connected to the system. There are several other directories in the root directory, but you do not need to use them during this course. All the files and directories in a Linux system are organized into one of these designated folders, depending on the purpose of the file or directory. In this video, you learned that the Linux system consists of 5 key layers. The operating system runs on top of the Linux kernel and is vital for system health and stability. The kernel is the lowest level software, and it enables applications to interact with your hardware. And all system files are organized within the Linux file system depending on their purpose. Welcome to Linux Distributions. After watching this video, you will be able to describe what a Linux distribution is, differentiate between some common Linux distributions, and identify the use cases of some popular Linux distributions. So, what is a Linux distribution? A Linux distribution is a specific flavor of the Linux operating system. It may also be referred to as a distro. All Linux distributions must use the Linux kernel. This is the core component of the Linux operating system that enables the system to properly use the computer's hardware. And today, there are hundreds of Linux distros, each tailored for a specific audience or task. Okay, so what differentiates Linux distros from each other? Each Linux distro includes a unique set of default utilities that are part of the operating system, such as commands and applications that come pre-packaged with the distribution. Each distro has its own graphical user interface, or GUI, that you use to interact with the operating system. Each distro supports a specific set of commands that you can use in a shell, a window for entering and receiving output from commands. And lastly, each distro provides differing levels of support. It could be developed and managed as a community-backed project or maintained by a commercial enterprise. And it could be a long-term support version, or LTS, or a rolling release, where stable package updates are released on a rolling schedule. Debian is one of the earliest rooted distros, with the first release in 1993, named version 0.01, and the first official stable release in 1996, version 1.1. It is known for being stable, reliable, and fully open source. It supports many computer architectures or types of hardware. These features result in Debian being highly regarded in the server space. And furthermore, Debian is the largest community-run distro currently available. Another popular distro is Ubuntu. This is also an early rooted distro with its first official release in 2004. Ubuntu is Debian-based, meaning that it's built on top of Debian and uses a lot of the same tools as Debian OS. Ubuntu is developed and managed by Canonical, and Ubuntu has 3 official editions: Desktop for personal computers, laptops, and workstations, Server for simple file servers or multi-node clouds, and Core for the Internet of Things. Red Hat Linux, like Debian, is a core Linux distro, meaning that it is not derived from another Linux distro. Red Hat is known for being stable, reliable, and fully open source. It's managed by Red Hat, an IBM subsidiary. Today, it ships as Red Hat Enterprise Linux, or RHEL, an edition focused entirely on enterprise customers. Next is Fedora, which is known as a stable operating system that supports many architectures. It's also very reliable and secure, offering unique firewall and security features. It's actively developed with a large and growing community, and it's sponsored by Red Hat. Consequently, Red Hat uses much of Fedora's code base, after testing, of course. Another Linux distro is SUSE Linux Enterprise. Also known as SLE, SUSE Linux Enterprise is available in 2 editions, Server or SLES and Desktop or SLED. It supports many architectures, such as ARM for Raspberry Pi, and uses the SUSE Package Hub, which enables users to install packages that aren't officially part of SLE. And it's maintained by the small German open-source software company, SUSE. And finally, we have Arch Linux. The unique do-it-yourself approach of Arch Linux allows users to customize every part of their system. This makes it highly configurable, a freedom that makes Arch very popular. But it also means that you need a strong understanding of Linux and system tools in order to use Arch effectively. And because Arch isn't focused on stability in the same way as other distros, it has easy access to the newest software, which has little guarantee of being completely stable. In this video, you learned that Linux distros can be differentiated by their user interfaces, their shell applications, and how the operating system is supported and built. The design of a Linux distro is catered towards a specific audience. Debian is highly regarded in the server space for its stability, reliability, and for being open source. Red Hat Enterprise Linux, an IBM subsidiary, is focused completely on enterprise customers. And SUSE Linux Enterprise supports many architectures, such as ARM for Raspberry Pi. Welcome to Linux Terminal Overview. After watching this video, you will be able to describe what the Linux shell is, describe what a Linux terminal is, explain how a Linux terminal and shell work together, and use a Linux terminal to navigate directories. The Linux shell is an OS-level application that interprets commands. In early versions of Unix and Linux, the shell was the only way to interact with the operating system. Today, you can also use graphical user interfaces, but the shell remains a popular and flexible choice and an easy way to run script files. You can use shell commands to perform tasks such as moving and copying files, writing to and reading from files, extracting and filtering data, and searching for data. There are many shell versions, but the base functionality of most is the same. Some popular examples include Bash and Zesh. You interact with the Linux shell through a Linux terminal. A terminal is an application or user interface where you enter the commands you want to run and receive any output from those commands. For example, to start the Python application and run a program called myprogram.py, type Python space myprogram.py. When you press enter, the shell runs the command. This program prints the words "Hello World" to the terminal. So, how are commands run? First, we have a user who wants to run a command. They enter the command in a terminal, which is then relayed to the shell. The core components of the operating system and kernel translate the command for the hardware to perform. When the hardware completes the command, the kernel reads any changes or results and sends them back via the shell to the terminal for the user's information. The terminal is a powerful way to run applications and interact with your machine. Now, most terminals have a similar user interface for you to enter commands. The area where you enter commands is called the command line, and the vertical line, or cursor, is the command prompt. This indicates where the text that you type will be displayed. In this example, the current working directory is the Documents directory, which is inside the Me directory, which is inside the Home directory. The current working directory is the location where the shell will look for any commands that you specify to run. For example, the Python program in the previous example. Not all terminals display the full location or path of your current directory, so some will just display documents here. The path is the human-readable location of a directory or file in the Linux file system. The A/B structure indicates that the file or directory named B is located inside the directory named A. There are also special paths. A single tilde symbol refers to the user's home directory. A single slash at the beginning of a path refers to the root directory. 2 periods refer to the parent of the current directory, and a single period refers to the current directory. So let's look at how you can use the terminal to change the current working directory. You use the cd command that stands for change directory. Enter cd/ to go to the root directory, and enter cd bin to move into the bin directory. The bin directory, which is inside root, contains programs required by the system. One of these programs, or executable files, is called ls. You can run the ls program in the current working directory by entering /ls. Use it to display in the terminal window the names of all files and directories within the current directory. Many commands located in the bin folder are also built into the shell, so you can run them from other locations too. Navigate to your home directory using cd tilde, and even though the current working directory /home/me does not contain the ls program, you can still run the command successfully. Let's look at some more examples. Again, starting at the /home directory, enter cd .. to change the current working directory to the parent of the existing current working directory. So in this example, the parent of /home is / or the root directory. To then navigate to a USB drive called My USB Drive in the media directory, enter cd /media/My USB Drive. You can also navigate up and down the tree in one command. To navigate up to the media directory, then up to the root, enter cd .. And then to navigate down to the documents directory in the me directory in the home directory, enter /home/me/documents. Press enter to submit the command and move to the documents folder. Let's move up to the /home/me directory. Start the Python application and run a program in the /home/me directory called myprogram.py. This program returns a message to the terminal window. In this video, you learned that a Linux shell is an OS-level application that you can use to enter commands and view the output of those commands. You use a terminal to send commands to the shell. And you can use the cd command to navigate around your Linux file system. Welcome to Creating and Editing Text Files. After watching this video, you will be able to list popular text editors for Linux, describe a popular GUI-based text editor, and use command line editors to work with a file. You use text editors to write code in your Linux environment. There are many editors to choose from, and they can be grouped into 2 main categories: command line text editors and GUI text editors. Examples of command line text editors are GNU Nano, a small and friendly modeless text editor, VI, a traditional command line editor originally created for Unix, and Vim, a powerful mode-based command line editor based on VI. A popular GUI-based editor is gedit, which is the default editor from the GNOME environment. And Emacs is another text editor that is one of the oldest free open-source projects still under development. You can use Emacs in GUI mode or within a command line. gedit is a popular modern text editor that comes pre-installed on most Linux distros. It's designed as a general-purpose text editor, and in keeping with the philosophy of the GNOME project, it emphasizes simplicity and ease of use with a clean and simple GUI. gedit provides many features to enhance your text editing experience, including an integrated file browser, undo and redo functionality, search and replace functions with support for regular expressions in the search string, and extensibility using plugins from the gedit plugins package. The text editor uses syntax color coding to help you interpret and focus on different aspects of your code. GNU Nano is a command line text editor that provides undo and redo features, search and replace with support for regular expressions in the search string, syntax highlighting, automatic indentation of code, line numbering, line-by-line scrolling, and multiple buffers so you can work with many files at the same time. To open a text file in Nano, type Nano followed by the file name to open. This opens a new text editor window in which you can edit the file. Here is what the Nano app looks like. The main area displays the text of the open file, which in this case is the source text from the Nano Wikipedia page. The cursor is currently located at the beginning of the file, but you can navigate within the text using the arrow keys, page up and down keys, or home and end keys. Any text you type is entered at the cursor. You can also delete text using the delete and backspace keys. Pressing enter starts a new line. At the bottom of the Nano window, there is a list of commands that you can use in the editor. To access the commands, simultaneously press Ctrl and the letter for the command. For example, to get help, press the Ctrl and G keys. Let's see how to use a few of the editing options. To search for a text string, you can press Ctrl-W to use the Where Is option. This opens a new pane at the bottom of the app window. And here's a closer view of that new pane. Within the square brackets, you can see the most recently searched string, which here is 1999. Type the string you want to find, for example, HTTPS, and press Enter. The cursor moves to the first instance of the search string it finds after the current position of the cursor here. Nano supports many other editing features, which you will explore in one of the labs for this course. Now, Vim is a traditional and very powerful command line editor. It takes some time to get accustomed to how it works, but with some practice, your fingers will develop muscle memory to accomplish all of your text editing tasks at speed. Entering Vim at the command prompt opens the Vim app. You can also specify a file name to edit a new or existing file. Vim has two basic modes: insert mode, where you enter text, and command mode, where you do everything else. After you start a Vim session, press I to enter insert mode. Type some text, for example, some text, and press the escape key to exit insert mode and switch to command mode. And the text is written to the buffer at the current cursor location. Now you are back in command mode, and you can save your file with a file name using the :save command, along with a file name such as example.txt. The buffer is written to the file, and a message is displayed showing the file name, that it is a new file, it has one line with 10 columns, and that it was successfully written. And now that your file already exists, you can use the more common :W command to write any changes to the file. To quit your Vim session, enter :Q. And to quit and discard any changes made since the last write operation, include the bang or exclamation mark, as in :Q bang. This was a very short introduction to Vim, but there are many commands that you can use to navigate the text buffer and perform operations, such as searching, copying, pasting, and moving text around. You'll get to practice some of these commands in an upcoming lab. In this video, you learned that you can use a variety of command line or GUI-based text editors to work with your Linux code. gedit is a GUI-based editor that provides many features to simplify your work. GNU Nano is a command line editor that provides similar functionality in a command line format. And Vim is another command line editor that uses insert mode to enter data and command mode to work with the file. So, you've seen how to use a text editor to work with existing files. This will be helpful as you learn how to use Linux commands to create files and append text to them. Welcome to Installing Software and Updates. After watching this video, you will be able to describe packages and package managers, differentiate between packages for Deb and RPM-based distros, use a package manager to install updates, and use a package manager to install software. Both software updates and software installation files for Linux operating systems are distributed in files known as packages. These packages are archive files containing the required components for either installing new software or updating existing software. You use package managers to manage the download and installation of packages. Different Linux distros provide different package managers. Some are GUI-based and some are command line tools. Deb and RPM packages are used by package managers in Linux operating systems. They are distinct file types containing software or updates for different Linux operating systems. .deb files are used for Debian-based distributions such as Debian, Ubuntu, and Mint. Deb stands for Debian. And .rpm files are used for Red Hat-based distributions such as CentOS, Red Hat Enterprise Linux, Fedora, and OpenSUSE. RPM stands for Red Hat Package Manager. Deb and RPM formats are equivalent, so the contents of the file can be used on other types of Linux OSs. If you find that a package that you want to use is only available in the other format, you can convert it using the alien tool. To convert packages from RPM format to Deb, simply use the alien command and specify the package name that you want to convert. To convert to RPM format, use the rswitch with the alien command. Package managers provide several benefits. They can automatically resolve dependencies between packages. They can notify you when updates are available. GUI-based package managers can automatically check for security and software updates on a regular basis. And they can automatically install updates or let you select and install just the ones you want. GUI-based Linux distro package managers include Package Kit and Update Manager. Update Manager is a GUI tool for updating Deb-based Linux systems. By default, Update Manager checks for software updates daily and automatically downloads and installs any security updates daily. All other updates are displayed weekly. You can also manually check for updates at any time. Update Manager will notify you when software updates are available. Select the updates you want to install, click Install Updates. If prompted, enter your user password and click OK. And Update Manager installs the updates in the background while you continue working. apt is a command line tool for updating Deb-based Linux systems. You use sudo apt update command to find available packages for your distro. The output for this command lists each available package, builds a dependency tree, and lets you know how many packages can be upgraded. To install the packages, use the sudo apt upgrade command. If you want to only install a specific package, you can use sudo apt upgrade package name. Package Kit is a GUI tool for updating RPM-based Linux systems. When updates are available, Package Kit displays a starburst icon in the notification area. It automatically checks for updates at a configurable interval, and you can also manually check for them at any time. Clicking the starburst icon opens the software update window, which lists all available software updates. Select the updates you want to install, and then click Install Updates. If requested, enter your password and click OK, and Package Kit installs the updates in the background while you continue working. Yum is a command line tool for updating RPM-based systems. Yum stands for Yellow Dog Updater Modified. To update all packages in your system, type sudo yum update. After you enter your password, Yum fetches all available package updates, and then it displays a summary of the updates and asks you to confirm the download. If confirmed, Yum downloads all the package updates and updates the packages on your system. And when finished, it displays the success message, Complete. You can also use command line tools to install new software. Use the apt command with the install switch to install a package on a Deb-based system. and use the yum command with the install switch to install software on an RPM-based system. Many software applications use package managers, such as the popular pip or conda packages, for managing Python environments. For example, assuming you already have a Python environment and the relevant pip package, you can easily install the popular pandas library used for data wrangling in Python. Enter pip install pandas to instruct the pip package manager to search for the latest pandas package, download the pandas package, check for dependencies and update as required, and install the pandas package. When the installation is complete, the package manager displays the new software version number. In this video, you learned that .deb and .rpm are distinct file types used by package managers in Linux operating systems. Deb and RPM formats can be converted from one to the other. Update Manager and Package Kit are popular GUI-based package managers used in Deb and RPM-based distros, respectively. And apt and yum are popular command line package managers used in Deb and RPM-based distros, respectively. Welcome to Overview of Common Linux Shell Commands. After watching this video, you will be able to define what a shell is, list shell command applications, and recall common shell commands. A shell is a powerful user interface for Unix-like operating systems. It can interpret commands and run other programs. A shell, which enables access to files, utilities, and applications, is also an interactive language. A shell is also a scripting language, and it can be used to automate tasks. The default shell on Linux systems is usually Bash. Other shells include the Bourne shell, SH, the Korn shell, KSH, TC shell, Z shell, and Fish. For this course, we will only use the Bash shell, which stands for Born Again shell. To find out what the default is, enter printenv shell on the command line. This returns the path to the default shell program, which in this case is Bash. If your default shell is not Bash, you can always switch to it simply by entering Bash on the command line. We will use the $sign to represent the command prompt throughout this course. Outside of this course, you may encounter the greater than symbol being used for the same purpose. Applications of shell commands include getting information, navigating and working with files and directories, printing file and string contents, file compression and archiving, performing network operations, monitoring performance and status of the system, its components and applications, and running batch jobs such as ETL operations. Some common shell commands for getting information include whoami, which returns the user's username, ID, which returns the current user and group IDs, uname returns the operating system name, PS displays running processes and their IDs, top displays running processes and resource usage including memory, CPU, and I/O. DF shows information about mounted file systems. Man fetches the reference manual for any shell command. And date prints today's date. Some common shell commands for working with files include CP, copy file, MV, change file name or path, RM, remove file, touch, create empty file, update file timestamp, change mod, change or modify file permissions, WC, get count of lines, words, characters in file, and grep, return lines in file matching pattern. Very common shell commands for navigating and working with directories include ls, lists the files and directories in the current directory, find, used to find files matching a pattern in the current directory tree, pwd, prints the current or present working directory, make dir, makes a new directory, cd, changes the current directory to another directory, and rmdir removes an entire directory. For printing file contents or strings, common commands include cat, which prints the entire contents of a file, more, used to print file contents one page at a time, head, for printing just the first n lines of a file, tail, for printing the last n lines of a file, and the very common echo command, which echoes an in-print string by printing it. It can also echo the value of a variable. Shell commands related to file compression and archiving applications include tar, which is used to archive a set of files, zip, which compresses a set of files, and unzip, which extracts files from a compressed or zipped archive. Networking applications include the following: hostname prints the host name, ping sends packets to a URL and prints the response, ifconfig displays or configures network interfaces on the system, curl displays the contents of a file located at a URL, and the wget command can be used to download a file from a URL. We should mention that if you happen to be running a Windows machine and you want to run Linux on it, you can do so in various ways. Linux can be installed on a separate drive partition. Switching between the two operating systems requires a reboot. Alternatively, you can install Linux on a virtual machine, or you can install a Linux emulator such as Cygwin, or use the Windows subsystem for Linux, a compatibility layer for running Linux binary executables natively on Windows. In this video, you learned that a shell is an interactive user interface for running commands, a scripting language, and an interactive language. Shell commands are used for navigating and working with files and directories. Shell commands can be used for file compression. The curl and wget commands, respectively, can be used to display and download files from URLs. The echo command prints string or variable values. And the cat and tail commands are used to display file contents. Welcome to Informational Commands. After watching this video, you will be able to find user information, determine operating system information, analyze disk usage, describe and verify system health, list running processes and their resource usage, and finally, execute additional miscellaneous commands and obtain information about them. The command Who Am I will display the user's identity. The Who Am I command takes no arguments and has no options. Here, you see a usage example of someone logged in as user John Doe. Similarly, the ID command returns the user ID and/or the user's group ID. Here you see an example where ID returns the numerical ID of the user with the -u option. If you would like the name corresponding to the numerical user ID, add the -n option. The uname command, which stands for Unix name, returns OS information such as the kernel name and version number. Entering the uname command returns the name of the operating system, which in this case is Darwin. Including the -s and -r options return both the OS name and its version. Alternatively, you can view all version information using the -v option. You can use the df command to display your system's disk usage. For example, entering df-h tilde displays the following table which is specific to tilde, your home directory, such as all disks mounted on your home directory and the percentage of storage used on each disk. The -h option makes the output human-readable, expressing disk space in units like gigabytes and terabytes instead of bytes. To view disk usage on all file systems, you can also just type df-h. The output includes the size, the capacity used, and available space for each file system. The ps command will display the currently running processes. You can use the ps command with the -u root option to show only the processes running with root user privileges. This includes information such as the name of each running process, the process ID, and the time in minutes and seconds that each process has been running. The top command acts as a task manager and will show running processes and their resource usage. Here, we show a usage example with the -n option to display the top 3 running tasks: Chrome, Top, and Spotify. By default, tasks are sorted by CPU usage. We simplified the output for the sake of the presentation, but Top provides many other details, like memory usage and the executable file location. The echo command prints the given string or the value of a given variable. In shell scripting, echo is commonly used as a print command. If you enter echo, you are basically saying print nothing, so you just get a new line. If you would like to echo a single word without white space, such as hello, you can just type echo hello. But if your string contains spaces, you need to use quotes. Then echo returns the quoted contents. Learning Linux is fun. And finally, you can view the value of a variable, such as path, by typing a $sign followed by the variable name. Here we view each path of our system's path variable delimited by colons. The date command displays the current system date and time. Entering date returns the default date format: day of week, day, month, year, time, and the time zone. You can extract parts from the date, like in this example, which prints 259 day of year. The %letter symbols in these arguments are used to extract properties of the current date. For example, %y is replaced by the current year 2021. And here's another example where you can see that the day of the week has also been included. All default Linux commands come with a manual that you can display using the man command. For example, you can enter man ID to display the manual for the ID command. You get information like return user identity stating what the command does, and also listed are the options for ID, such as -a. Square brackets are used to indicate optional parameters, such as user, which allows you to specify a user name. A detailed description of the command is also provided, and the man command even has its own man page. In this video, you learned how to get user information with the whoami and ID commands, check system disk usage using the df command, see process load using ps and top, print string or variable value using echo, view the date in different formats using the date command, and finally, read the manual for any command using man. Welcome to File and Directory Navigation commands. In this video, you will learn how to list directory contents, navigate directories, and find files. The ls command will list the files and directories within a directory. If you enter ls in your home directory, you will see all files and directories that your home directory contains. You can also pass a directory name, such as downloads, as a parameter to ls, which displays the contents of your downloads folder. The ls command also supports further options to provide additional information. Now, suppose you are currently working in your Documents folder. You can use ls with the -l option, which will show child files and directories in a longer, more detailed format. And you can see all child files and directories along with additional details such as permissions, last modified date, and owner. The pwd command will print the present working directory. You can enter pwd whenever you are not sure which directory you are in. Here, you can see that you are currently working in your home directory, /user/me. The cd command is used to change the current working directory. Now suppose you are in your home directory and you wish to move to your Documents folder, which happens to be contained in your home directory. You simply enter cd Documents. Now, if you enter pwd, you can see that you are indeed in your Documents folder. The cd command enables you to change directories with either an absolute path to the directory, which always starts from the base or / directory, or as relative path, which starts from your current working directory. Now imagine you are in a Notes folder somewhere in your Documents directory tree. To get to your immediate parent directory, you can simply enter the cd command along with the relative path symbol ... as its argument. Now you can see you are in Math, which is the parent directory of your Notes folder. If you want to get to your Home folder directly without having to explore to get there, then you can simply use the tilde symbol. And you are now in your Home folder. Tilde represents your absolute path to Home. Finally, you can provide a full path to a directory. Here you are referring to the absolute path name for the Notes directory from where you started your journey. And as expected, you are now back where you started, in your Notes directory. The find command is a powerful tool that will find the path to every file that matches a given user-specified criterion. Now suppose your Documents folder has a file structure as shown with 2 subfolders, each containing a few files. And let's say you are currently in your Documents folder and you want to find the path to all files called a.txt within your Documents tree. To do so, you can simply type find.-name a.txt. The dot argument means search within here, that is, from your current working directory. To perform a case-insensitive version of your search, you can use the -iname option instead of iname. And indeed, you find the same file plus another file with the same name, except that the letter A is uppercase. In this video, you learned that the ls command lists all files and directories contained within a specified directory tree, and you can navigate directories using the cd command. Welcome to File and Directory Management Commands. In this video, you will learn how to create and delete files and directories, copy and move files and directories, and change a file's permissions to make it executable. The make-dir command is used to create directories. Let's say you are currently in your Documents folder, which is currently empty. To create a folder called Test, you simply enter make-dir test. Now your current directory has a subfolder called Test. The rm command allows you to remove a file or directory. Suppose you have a file structure as shown on the left, and let's say you are in the Documents folder and you wish to remove File 1. You can do this by simply typing rm file 1. Now you can see only folder 1 is left. You cannot simply remove folder 1 since it may contain other files. However, you can easily get around this by entering rm with the -r option. The -r option means you want to remove the directory along with all its child file objects. Your Documents folder is now empty. Accordingly, you should always be careful when using rm with the -r option. It is very easy to accidentally remove folders of important data. Now suppose you create an empty directory with the mkdir command, and you would like to remove it. It is not recommended to use rm-rf. Instead, you should use the rmdir command, which is used solely to remove empty directories. This guarantees that you'll never accidentally delete any important files or directories. Entering ls shows the current directory is indeed empty. The touch command can be used to create empty files. Suppose you are in your Documents folder, which is empty, and you wish to create some empty text files. You could do this by entering touch along with some file names A, B, C, and D with the .text suffix. Now you can see that your Documents folder contains the 4 files you created. You might be wondering what the touch command does to a file that already exists. Suppose your current directory contains a file called notes.txt. You can see when it was last modified using date -r notes.txt. If you use the touch command on notes.txt, you can see that its last modified date updated to the current time. The cp command allows you to copy a file or directory. To copy files, you can either copy a file from a source directory and specify any file name for the copied file in its destination directory, or simply omit the destination file name and default to keeping the same file name. To copy entire directories, you need to give CP the -R option so that it knows to recursively copy all subdirectories and files. Let's look at some examples. Suppose you have a file called notes.txt and a folder called documents in your working directory. You can copy notes.txt to your documents folder using cp notes.txt documents. Now you can see that your documents folder contains a copy of notes.txt. Notice that you didn't need to specify a source directory because cp defaults to your current directory. Next, you can create a copy of your documents folder called docs_copy using the syntax from the left. And as expected, you now have a docs_copy folder containing the same contents as our documents folder. The mv command allows you to move a file or directory. To move files, you can enter mv followed by the paths of the files you want to move, followed by the folder you want to move them to. Likewise, to move directories, you type mv paths of directories to move, followed by the directory you want to move them to. Let's look at an example. Suppose you have a file called myscript.sh and 3 folders called scripts, notes, and documents. You can move my_script.sh to your scripts folder using the syntax from the left. Accordingly, entering ls my_script.sh returns nothing. But indeed, entering ls scripts shows that you successfully moved my_script.sh to your scripts folder. Next, you can move your notes and scripts folders to your documents folder using the syntax from the left. Perfect! You can see that your directory now just contains your documents folder, and that your documents folder contains the scripts and notes folders that you just moved. chmod stands for change mode and is used to change, read, write, and execute permissions on files. Suppose here you have created a shell script file in your current directory called my_script.sh that echoes "Learning Linux is fun." Entering ls -l my_script.sh shows that your shell script has read and write permissions as indicated by the R and W characters. But if you try to execute the file, you get a permission denied error. In order to make your script executable, you call chmod on my_script.sh with the +x option. Entering ls -l my_script.sh now shows that my_script.sh has executable permissions as indicated by the X character. Great! Running the script now works. In this video, you learned that you can use the touch command to create a new file or update the last modified date of an existing file. You can create a directory with the mkdir command and delete an empty directory with the rmdir command. You can use the cp and mv commands to copy, move, and rename files and directories. And you can use chmod to change, read, write, and execute permissions on files. Welcome to Viewing File Content. In this video, you will learn how to apply commands that operate on files to view the contents of a file in useful ways and determine line, word, and character counts. There are several useful commands for viewing file content. To begin with, you can use the cat command to print the entire file to standard output. Suppose your current directory contains a single file called numbers.txt, which you can see by entering the ls command. To print the contents of this file to standard output, you can type cat numbers.txt, which produces the output shown here, consisting of the numbers 89 through to 99. You can see that the output takes up the entire terminal window. The file is much longer than the 12 lines you see here, and for this reason, you might not always want to use cat to view contents. Thankfully, there are alternative commands for cases such as these. The More command allows you to view a file's content in a page-by-page format. By entering more numbers.txt, you see the numbers 0 to 8 on page 1 as shown. By page, we just mean the current terminal window. If you expand your terminal window vertically, you also increase the page size. And when you click the spacebar, you will see the next page, which displays the numbers 9 through 17. Entering Q quits the More program and returns you to the command prompt. You can use the head command to print the first 10 lines of your file. Entering head numbers.txt returns the first 10 lines or the numbers 0 through 9 as shown. You can specify the number of lines you would like head to return using the -n option. By entering head -n 3 numbers.txt, you get back the first 3 lines of numbers.txt as 0, 1, 2. The tail command is used to print the last 10 lines of a file. Entering tail numbers.txt returns the last 10 lines of numbers.txt, namely the numbers from 90 through to 99. Just like with the head command, you can use the -n option to change the number of lines returned. By entering tail -n 3 numbers.txt, you get back the last 3 lines of numbers.txt, 97, 98, and 99. You can use the WC command to count the number of characters, words, or lines in your file. Imagine you have a file called pets.txt. Entering catpets.txt shows that the file contains the word cat or the word dog on each line. By entering WC pets.txt, you get the result 7728 pets.txt, which means that your file contains 7 lines, 7 words, and 28 characters. But 7 times 3 is 21, so why does WC see 28 characters? Because it also counts new line characters. You can't see them there, but there are 7 new line characters, one of which represents end of file. To view only line count, you can use the -l option, which returns 7 pets.txt. And similarly, to view only word count, you can use the -w option. And to view only character count, you can use the -c option. In this video, you learned how to apply the cat, more, head, and tail commands to view file contents in multiple ways, and determine the line, word, and character count of a file using WC. Welcome to Customizing View of File Content. In this video, you will learn how to apply commands that operate on files to create a line-by-line sorted view, create a view with repeated lines excluded, extract lines containing a specified pattern, extract slices and fields from each line, and merge lines from multiple files. The sort command sorts the lines of a file alphanumerically and prints the sorted result to standard output. By entering sortpets.txt, you get back the alphabetically sorted output with cat repeated 5 times and dog repeated twice. If you enter sort-rpets.txt, you get back the lines sorted in the reverse order, with the dog lines appearing before the cat lines. If you have repeated lines in your file, you can use the unique command to filter out the repeated lines. Recall the contents of pets.txt by entering catspets.txt. By entering unique pets.txt, you get back cat, dog, and cat. Notice that the unique command only removes duplicated lines if they are consecutive. Thus, the word cat appears twice, because in your file, cat appears before and after the 2 dog lines, which breaks the cat sequence. The grep command, which stands for Global Regular Expression Print, returns lines of a file matching a specified pattern, such as a regular expression. Suppose you have a list of famous people's names stored in a file which you view by entering catpeople.txt. You can use grep to find all lines in people.txt that contain the consecutive characters C and H. To do this, you give grep the matching term CH followed by the file name. The output returned 2 results, Dennis Ritchie and Erwin Schrödinger, both containing a lowercase match to CH. Performing the same operation, but this time with the -i option, returns an extra result, Charles Babbage, which has an uppercase C. This is because the -I option expands the pattern search by making it case insensitive. You can use the cut command to extract specific sections from each line in your file. Here you see the list of famous names again, such as Alan Turing and Charles Babbage. You can use the cut command to extract characters 2 to 9 from every line by entering cut-c 2-9 people.txt. You can see from the output that, for example, Alan Turing is returned as Lanturi or Lanturi. Let's look at perhaps a more useful example for this sort of text file. Suppose you want to extract just the last names of each person in your list. You know that each line of your list is made up of 2 fields. One is the first name and the other is the second name. These fields are separated by a space. Here, you're cutting to extract the second field from each line using the -F2 option, and you specify that the field delimiter is a space using the -D quote space quote option. The result shows that you get back the last name of each person from the list just as you wanted. You can use the paste command to merge lines from multiple files. Imagine you are given the following 3 text files, all with the same number of lines. A text file called first.txt containing a list of people's first names, a complementary text file called last.txt which contains the last names of the same people, and a third text file called yob.txt which lists each person's year of birth. You can view these files as a table by entering paste first.txt, last.txt, yob.txt. Notice the 3 columns are nicely aligned. This is because paste uses a tab as the default delimiter. And, for example, you can see that Charles Babbage was born in 1791. You can specify a delimiter other than the tab with the paste command using the -D option. For example, you can use a comma as a delimiter by entering paste-D with a comma surrounded by double quotes together with the first, last, and yob text files. And you get the desired result where you can see, for example, Dennis, Ritchie, 1941. In this video, you learned how to use grep to get the lines of a file matching your desired criteria, and to create various views from file contents using the sort, unique, cut, and paste commands. Welcome to File Archiving and Compression Commands. After watching this video, you will be able to distinguish file archiving from file compression, create archived files and unpack them, and apply commands to compress, decompress, and extract files from archives. Archiving and compression are distinct processes which are usually combined. Archiving is the process of storing information that you don't use regularly, but want to preserve. An archive file is a collection of data files and directories that are stored as a single file. Archiving makes the collection more portable and serves as a backup in case of loss or corruption. File compression, on the other hand, involves reducing the size of a file by taking advantage of redundancy in its information content. The main advantages of compression include preserving storage space, speeding up file transfers, and reducing bandwidth loads. Now, suppose you have created a notes directory for keeping track of your course materials. You decide it would be a good idea to archive your notes in case you need them in the future. Your notes directory tree has the following structure. It contains 2 subfolders called Math and Physics, each of which contains files called by the same names, Week 1 and Week 2. Using the ls command with the -R option, you can recursively list all the directories and files in your current directory tree. You can see the correspondence with the graphical representation of the tree, starting with the parent notes directory, the Math and Physics subdirectories, and the Week 1 and Week 2 files within the Math and Physics folders. You can use the tar or tape archiver command to archive and de-archive files and directories. A popular term for an archived tar file is a tar ball. To archive your entire notes directory, including its subdirectories and all files within, enter the command tar-cf, a name for the archived file such as notes.tar, followed by the file or directory you wish to archive, which is notes. The C option means create a new archive, and the F flag tells tar to interpret its input from file rather than from the default, which is standard input. Entering ls shows that your current directory now contains the original notes folder as well as the notes.tar archive file. If you would also like your archive to be compressed, you can enter the same command, except now you include the -z option, which filters the archive through a GNU compression program called gzip. Adding the suffix .gz to the output name ensures that Windows-based programs, for example, will correctly recognize the file type. Entering ls now shows the compressed notes.tar.gz file that you created. You can check the contents of your archived notes file by calling tar on your notes tar ball with the -t or list option. This lists all the files and directories in your tar ball. And as expected, it has the same structure as your original notes folder, with notes as the parent directory, math and physics as subdirectories, and week 1 and week 2 files at the terminal nodes. You can also unpack or de-archive your archived files using the tar command. You can enter tar-xf, followed by the archive file name, notes.tar, plus an optional destination name, for example, notes, which happens to be the default. The -x option tells tar to extract file and directory objects from the archive. Now, if you enter ls-r, you can see that the archived notes folder has been de-archived into a parent folder called Notes, subfolders called Math and Physics, and the 4 week 1 and 2 files you started with. This verifies that the original structure of your notes directory is intact. Similarly, you can decompress a tar.gz file and extract the files from it. To unpack and decompress the notes.tar.gz file, you can enter tar-xzf followed by the compressed archive file name, notes.tar.gz, and an optional destination folder, Notes. Again, by entering ls-r, you can see the directories and files have been unpacked as expected. You can use the zip command to compress files and directories and package them into a single archive. Notice the order of operations that zip implements. Zip compresses files prior to bundling them, whereas tar, with the -z option, achieves compression by applying gzip on the entire tar ball, but only after bundling it. To compress your notes directory and package it to a zip file, enter zipnotes.zipnotes. And after entering ls, you can see that the notes.zip archive has been created. The unzip command, as you might guess, extracts compressed files from a zip archive and decompresses them. To unzip your notes.zip file, simply enter unzipnotes.zip. After entering ls-r, you can see that unzip has created your notes folder and unpacked your directories and your week 1 and 2 files as expected. In this video, you learned that the main advantages of file compression include preserving storage space, speeding up file transfers, and reducing bandwidth loads. You can use the zip command to compress files and directories and package them into a single archive of compressed files. You can use tar to archive files and directories into a tar ball, and optionally apply gzip compression to the tar ball file. You can use unzip to unpack and decompress a zipped archive. And finally, you can use tar to decompress and unpack a tar.gz archive. Welcome to Networking Commands. In this video, you will learn how to examine your network configuration, evaluate the stability of a URL connection, and identify and retrieve data from a URL. The host name command is used to get or set the host name and other information which uniquely identifies your computer. Entering the host name command without any options returns the host name of your machine, which in this example is mylinuxmachine.local. The .local suffix appears in the host name if your machine has local domains set. To drop the domain suffix, you can include the -s option. If you use the -i option, hostname will provide the IP address of the host name. The ifconfig command, which stands for Interface Configuration, displays information regarding all your device's communication devices. If you enter ifconfig with no options, you get a lot of information, including the IP address, MAC addresses, and the hardware specifications of your communication devices. A lot of this information is beyond the scope of this course and would be more useful for system administrators. You can also specify a specific device you want ifconfig to inspect, such as an Ethernet adapter called ETH0. Entering ifconfig ETH0 returns information about your Ethernet adapter, such as its internet address, the number of packets received including counts of errors and dropped packets, the same metrics applied to transmitted packets, and the total amount of data received and transmitted. You can use the ping command to test connectivity to a host or IP address. Ping sends packets known as ICMP or Internet Control Message Protocol requests to the server, listens for a response, and prints a result. For example, by entering ping google.com, Ping returns a line of info for each successful response to an echo request and continues until you abort with Control-C. And after ping aborts, it prints summary statistics for the ping results. For each echo request, ping reports useful information, including the IP address of the given URL, 142.251.41.68, and the total round-trip time in milliseconds. The provided statistics at the end include how many packets were transmitted and received, the percentage of packets dropped, and the minimum, average, maximum, and standard deviation of the round-trip times in milliseconds. If you would like the ping command to return a set number of ping results, you can use the -c option. Entering ping -c 5google.com returns the 5 ping results, aborts, and then prints the same statistics it would print without the -c option. The curl command is a powerful tool which enables you to transfer data to and from URLs and supports many different protocols. Entering curl www.google.com returns the entire HTML content of the landing page at www.google.com using the default HTTP protocol. You can see, for example, the path to a PNG file for the Google G logo. You can render the logo by appending its path to google.com in your browser. You can even get curl to write the contents of a URL to a local file. This is done using the -o option. For example, you can enter curl www.google.com together with the -o option and a file name such as google.txt. You can then view the contents of google.txt using the head command and verify that the file contents indeed match the previous output. Similar to curl, the wget command is used to retrieve files located at a URL. Wget is like curl in that it can retrieve a file located at a URL or the HTML code for a web page, but it is more specialized in its protocol support and has recursive downloading capabilities. This is useful when a URL might point to a folder that contains several files. Here, you use wget to download a single test file called ISO_8859-1.txt, which is hosted by w3.org. wget returns information while it is downloading, such as resolving and connecting to the target server, HTTP requests sent awaiting response, and saving the file which it automatically names for you to the current directory. For reference, here is what your browser shows you when looking at the data located at the URL. It's a simple text file. By entering head-n 12 ISO_8859-1.txt, you see the first 12 lines of the contents of the downloaded file. As expected, the file contains the exact same data that you just saw on the previous slide. In this video, you learned how to view network configuration with hostname and ifconfig, test a network connection using the ping command, and send and receive data using the curl and wget commands. Welcome to Shell Scripting Basics. After watching this video, you will be able to outline what a script is, list use cases for scripting, describe the shebang interpreter directive, and create and run a simple Hello World shell script. A script is a list of commands that can be interpreted and run by a program called scripting language. Commands can be entered interactively at the command line or listed line by line in a text file. Scripting languages are usually not compiled. They are interpreted at runtime. Scripts are generally slower to run than compiled languages, but they are also much easier and faster to develop. Scripts are widely used to automate processes, such as ETL jobs, file backups and archiving, and general system administration tasks. You can use scripts for nearly any computational task, including application integration and plugin and web application development. A shell script is an executable text file in which the first line usually has the form of an interpreter directive. The interpreter directive is also known as a shebang directive, which has the following form: #bang interpreter plus an optional argument. Interpreter is an absolute path to an executable program, and the optional argument is a string representing a single argument. Shell scripts are scripts that invoke a shell program. For example, #bin/bin/sh invokes the Bourne shell or other compatible shell program from the bin directory. #bang/bin/bash shebang invokes the bash shell. Shebang directives aren't limited to shell programs. For example, you could create a Python script with the following directive: #bang/user/bin/env python3. Here we demonstrate how a shell script can be used to run a program with a simple Hello World example. From the command prompt, you can create a simple Hello World shell script as follows. Use the touch command to create an empty text file called hello-world.sh. The .sh extension is a convention used to indicate that the file is a shell script. Now, turn your text file into a bash script by echoing the bash shebang and appending that echoed text to your file using the double greater than symbol, which is the bash output redirection operator used for appending output to file. Finally, use the echo command to print the statement echo hello world and again redirect that output to your bash script. Before you can run your bash script, you need to make it executable. First, check the current permission settings of your script by using the ls command with the -l option. The R and W entries indicate that the script is readable and writable, but the lack of an X means it is not executable. The R, W, and X entries apply to 3 user-based permission groups: the owner, which is you, the group, and all users. You can make it executable for all users by invoking the change mod command with the +X option. Checking the permission settings now shows that your script is executable for all users due to the X entries for all 3 permission groups. Now you can finally run your bash script by typing /helloworld.sh and pressing enter, and the text Hello World appears on the command line. In this video, you learned that a shell script is an executable text file that begins with a shebang interpreter directive. A shell script can be used to execute commands as well as run other programs. Scripting languages are not compiled, they are interpreted at runtime. And compiled languages may be much faster than scripting languages, but they also require more development time. Welcome to Filters, Pipes, and Variables. After watching this video, you will be able to outline the following Bash shell scripting features: describe and use pipes and filters, and explain and set shell and environment variables. Filters are shell commands, or programs, which take their input from standard input, normally the keyboard, and return their output to standard output, which is normally the terminal. We can think of a filter as a transformer, a program that transforms input data into output data. Here are many examples, including word count, cat, more, head, sort, grep, and so on. The value of filters is that they can be chained together, which brings us to the pipe command. The pipe command, denoted by a vertical slash, immensely extends the functionality of shells. It allows you to chain together sequences of filter commands. The use pattern looks like this. Accordingly, the output of command 1 becomes the input of command 2, and so on. And not surprisingly, pipe is short for pipeline. For example, you can pipe the output of ls to the sort command with the -r option, which results in a reverse sorted list of directory contents. Shell variables are variables that are limited in scope to the shell in which they were created. Accordingly, shells cannot see each other's shell variables. You can invoke the set command to list all variables and their definitions that are visible to the current shell. Because it also lists a lot of subsequent information, you can pipe the output to head in order to show just the first 4 variable definitions. To define a new shell variable, simply use the equal sign to assign a value to your chosen variable name. Notice that there are no spaces around the equal sign. As an example, let's define a shell variable called greetings, which stores the string hello. To see the contents of the new variable greetings, use the $sign to access its value, then echo it back. You can display multiple variables as well. Let's define another variable, audience, with the value world. Then, echoing both variables back returns hello world. To clear a variable, use the unset command. For example, unset audience deletes the variable audience. Environment variables are just like shell variables, except they have extended scope. They persist in any child processes spawned by the shell in which they originate. You can extend any shell variable to an environment variable by applying the export command to it. For example, export greetings makes greetings an environment variable. To list all environment variables, use the env command. Let's check whether greetings was exported as an environment variable by piping the output of env to grep and filtering the results using the pattern gree. Indeed, greetings is now an environment variable. In this video, you learned that filters are shell commands or programs such as word count, cat, sort, etc. that transform the input provided to them. The pipe operator can be used to create a pipeline of chained filter commands, whereby output of one command becomes the input of another command. Shell variables can be assigned values with a simple equal sign and listed using the set command. And environment variables are shell variables with scope extended to all child processes of the shell. They are created using the export command and listed using the env command. Welcome to Useful Features of the Bash Shell. After watching this video, you will be able to outline the following Bash Shell scripting features: meta characters, quoting, input-output redirection, command substitution, command line arguments, and batch versus concurrent modes of execution. Metacharacters are special characters that have meaning to the shell. The pound symbol is used to include comments which are ignored by the shell. For example, this comment does not return anything. The semicolon is a metacharacter used to separate commands typed on the same line. For example, these two commands return their outputs on two lines like this. The asterisk is used to represent any number of consecutive characters within a file name pattern. For example, this expression returns all objects in the /bin directory with name starting with BA and followed by any characters, which in this case is bash. And the question mark acts as a single character version of the asterisk metacharacter. For example, this expression lists all objects in the /bin directory having a single character in place of the question mark, namely the bash and dash paths. Quoting is used to specify whether the shell should interpret special characters as metacharacters or escape them. You can use the \/ to escape interpretation of a single character as a metacharacter. Here, the \/ tells bash to interpret the $sign as text rather than the default variable name, so the output is literally $1 each. Double quotes will interpret text literally, except for any metacharacters, which will be interpreted according to their special meanings. For example, the $1 expression without the preceding \/ is interpreted as a variable, which in this case is empty, as we see here. Notice that it printed the space before each. Single quotes, on the other hand, are used to interpret all contents as literal characters. For example, this expression returns the same result as the first example above. Input-output, or I/O redirection, refers to a set of features used for redirecting either the standard input, which is the keyboard, or the standard output, which is the terminal. The greater than symbol is used to redirect standard output of a command to a file. It also creates the file if it doesn't exist, and overwrites its contents if it already exists. You can avoid overwriting by using the double greater than symbol, which appends output to any existing content. The combination to greater than redirects an error message to a file. To append the error message, for example, to an error log file, just add another greater than sign. And lastly, the less than sign is a redirection which is used to pass file contents as input to the standard input. Let's look at a few examples. You can start by simultaneously creating a file and populating it with some text, like this. You can then cat the file to see what's there. As you can see, line 1 was written to eg.txt. Now, you can try adding another line to the file. And viewing the contents again, you can see that the file contains exactly the 2 lines you added. Entering something like the word garbage returns an error. This expression catches the error message and redirects it to the file err.txt. And indeed, the contents of err.txt is what can be expected. You can use command substitution when you want to replace a command with its output. There are 2 equivalent notations. In the first, the command is encapsulated by parentheses with a $sign out front, while in the second, the command is encapsulated within backticks, also known as back quotes. Let's say you want to store the current directory path in a variable called here. You can use command substitution on the pwd, or present working directory command, to capture its output and assign it to the variable here. And indeed, echoing its value returns the current directory. Command line arguments are arguments used by a program that are specified on the command line. In particular, they provide a way to pass arguments to a shell script, which is itself a program. Command line arguments for a bash script are specified like this. Here, the arguments arg1 and arg2 are passed to mybashscript.sh. Bash has 2 main modes of operation. Batch mode, which is the usual mode, runs commands sequentially. For example, these 2 commands, separated by the semicolon metacharacter, will be executed in a particular order. Command 2 only runs after Command 1 is completed. In concurrent mode, commands run in parallel. The ampersand operator after Command 1 directs Command 1 to operate in the background and passes control to Command 2 in the foreground. In this video, you learned that meta characters are special characters that have meaning to the shell. Quoting is used to specify whether the shell should interpret special characters as meta characters or escape them. Input-output, or I/O redirection, refers to a set of features used for redirecting. You can use command substitution when you want to replace a command with its output. Command line arguments provide a way to pass arguments to a shell script. And finally, in concurrent mode, multiple commands can run simultaneously. Welcome to scheduling jobs using cron. After watching this video, you will be able to schedule cron jobs with cron tab, understand the cron syntax, and view and remove cron jobs. Whether you are a system administrator or a data engineer, or even a developer, there may be times when you want to schedule certain jobs to run automatically at certain times. For example, you may want to schedule a load script to run every day at midnight and a backup script to run every Sunday at 2 a.m. The cron utility on Linux and Unix-like operating systems allows you to do just that. Cron is the general name of the tool that runs scheduled jobs consisting of shell commands or shell scripts. Cron is the daemon or service that interprets cron tab files every minute and submits the corresponding jobs to cron at scheduled times. A cron tab, short for cron table, is a file containing jobs and scheduled data. Cron tab is also a command that invokes a text editor to allow you to edit a cron tab file. Entering cron tab -e on the command line opens the default text editor. Using the editor, you can specify a new schedule and a command, which has the following syntax. Command can be any shell command, including a call to a shell script. The symbols stand for minute, hour, day of month, month, and day of week. All 5 positions must have either a numeric entry or an asterisk, which is a wildcard symbol that means any. For example, the following syntax means append the current date to the file sundays.txt at 15:30 every Sunday. Closing the editor and saving the changes adds the job to the cron table. Let's take a closer look at each of these steps. Entering cron tab -e on the command line opens the default text editor. In this case, the default editor is GNU Nano. Conveniently, instructions for setting up cron jobs are included here as comments. Instructions for using the editor are also included, but you likely will only need Ctrl+X in this context. Here I have entered 3 example cron jobs. Notice that the extra spaces are ignored, so to improve the readability, you can align your entries as columns under the header. The first entry instructs cron to append the current date to the file sundays.txt at 15:30 every Sunday. The next line specifies a load data shell script to run at midnight every day, while the last line results in cron running the backup data shell script to run at 2 a.m. on Sundays. To save the job, first type Ctrl+X to exit the editor, then enter Y to save your changes. The jobs are now in production. Running cron tab with the L option returns a list of all cron jobs and their schedules. I use tail to avoid returning all of the comments from the cron tab file. To remove a job, simply invoke the cron tab editor, delete the corresponding line in the cron tab file, and save the changes. In this video, you learned that cron jobs can be scheduled to run periodically at selected times. Minute, hour, day of month, month, day of week, and command is the cron job syntax. Cron jobs can be edited running cron tab -e, and cron tab -L lists all cron jobs in the cron table.